Okay, so now we're going to talk about schema-based memories. And to start off, I need to first talk about what a schema is. So a schema, you can define it in a variety of ways. The way I like to describe it, and it's a totally reasonable way, is it's an organized set of propositions that describes the general characteristics of something or activity. And it's stored in semantic memory. Okay. And semantic memory is just like memory for trivia, memory for facts, basically. Uh, and so if you think of it, right, if you have we all have like a restaurant schema, for example. We have all kinds of schemas, and they kind of set our expectations about, what to, they set our expectations, right? What should we expect next, right? And they help us, they guide our understanding of things, and they also, as we'll see, guide our memory. So let's imagine the restaurant schema. Let's take that as an example. It's like sort of a classic example that people talk about, right? So you know, a restaurant schema, there's two roles. There's many roles, but two roles that we can talk about are customer and server. They're both humans, of course. And well, what happens? Well, the customer enters the restaurant, customer sits at the table, the server greets the customer, a bunch of other things happen, and then the check is brought to the customer by the server. Customer pays the check, and then the customer leaves the restaurant, right? And so these are just all like a collection of propositions that make up the restaurant schema, or maybe you could call it a script. Okay. And we can think of it like this from a network perspective, right? A human, waiter is a human, customer is a human. Well, what happens? Well, the customer enters the restaurant. That's the first thing. They look for a table, maybe. Then the customer sits at a table. Customer picks up a menu or the waiter goes to the table, right? And the orders in the table, I guess, I don't know what that means, but it's okay. And then the waiter takes the order, right? And I think that's it. Okay, so those are some examples of the schema for restaurant schema. And so to talk about this, I want to talk about actually I'm going to put up a heading on this next one. Sorry, I forgot the heading, but I'll put it up. And this is called what we call is schema instantiation inferences. And all this is you have a schema, and all you're doing is you're linking those propositions to a schema that you have, right? So, for example, if you heard the sentence, John went to White Horse and he sat down. Great. Okay, so we know that restaurant schema customer goes to the restaurant, right? Well, we know that John is a customer and Whitehorse is a restaurant, right? So those would just be schema instantiation inferences. And a lot of people get this one confused with the next one, but all the schema instantiation inferences is it's just linking concepts, incoming text to a restaurant, or sorry, to a schema. That's it. That's all it is. Okay. So you're inferring that John is an instantiation of the customer concept within the restaurant schema, if that's how you want to think about it. That's sort of a succinct way of thinking about it. Okay, so now I'm gonna show you a big long text. I'll read it out loud, and that's it. That we're and then I'm and then yeah, and then I'll tell and then we'll go from there. Okay, so first we'll just read this. The procedure is actually quite simple. First, you arrange things into different groups. Of course, one pile may be sufficient depending on how much there is to do. If you have to go somewhere else due to lack of facilities, that is the next step. Otherwise, you're pretty well set. It is important not to overdo things. That is, it is better to do too few things at once than too many. In the short run, this may not seem important, but complications can easily arise. A mistake can be expensive as well. At first, the whole procedure will seem complicated. Soon, however, it will become just another facet of life. It is difficult to foresee any end to the necessity for this task in the immediate future, but then one can never tell. After the procedure is completed, one arranges the materials into different groups again. Then they can be put into their appropriate places. Eventually, they will be used once more, and the whole cycle will have to be repeated. However, that is part of life. Great. Now, Some people will read this and go, I have no idea what this is about. What did you just read me? Some people are going to be able to correctly probably get it. It's not that hard, but it's very complicated, right? It's very ambiguous what this text is about. And so in one study, participants read this just like we did. And then that was one group. But in the other group, they were told that this is about laundry, doing laundry, washing clothes, right? And if you're told that, this is what happens, right? Um, so if you're washing clothes, right, notice how if you're given that title of washing clothes, participants rated how well they comprehended the story, right, or the instructions, better if they got the title. But not only that, but they were also more likely to remember concepts or ideas embedded in that story if they were told it was about washing clothes, right? So this is important because why is this relevant to the schema instantiation inference? Well, if you don't know that it's about washing clothes, you can't connect the text to the restaurant or the clothes washing schema, right? So that shows us that schema instantiation inferences are extremely important for memory, right? And that is the positive aspect of schemas. So we're going to do a lot of studies in here. We're going to talk a lot about how schemas are bad, right? But that's not true. There's a lot of benefits of schemas, and they really do help you a lot. So hopefully you don't come away thinking that schemas are always bad. Okay, now we're going to talk about bridging inferences, and they're just sort of a side effect of schemas, and they can actually lead to negative consequences if those bridging inferences aren't correct. So, for example, and bridging inferences, they're simply inferences that fill in gaps in the text by using information from the schema. So it's slightly different than a schema instantiation inference, right? So, for example, John went to the White Horse. Great. He ate and left. Okay. Now, the schema instantiation inference is going, hey, John is a customer, White Horse is a restaurant. That's the schema instantiation inference. The bridging inference is, well, he left, he ate and left. Well, what do you do after you eat and but before you leave? Well, usually you pay your bill, right? And so that right there is a bridging inference. The bridging inference is that John paid his bill, though he may not have. You don't know that, right? So that's the negative consequence, is that this could be a false inference that stems from simply trying to use the schema of restaurants to fill in the gaps. And we can show this with another one. Here's another example. So this is an actual study that was done. Um, So, yeah, a camper carelessly threw a match. A great forest was destroyed, right? So, camper threw a match. A forest was great and it was destroyed. Okay. Well, what's the bridge and inference? The bridge and inference, if you consult the forest fire schema, right, you know that campers usually throw matches into the forest and that's what causes fires, right? Or at least that's what the schema might tell you. It's usually just like heat and wind or something. I don't know. But anyways, it doesn't matter. Okay. And they found that in this sort of study, they found that participants, right, not surprisingly, their memory, so they were asked, did you see this sentence? A great forest was destroyed. Okay. And 20 minute, or sorry, if they were given that question, immediately after seeing it, the sentence, they responded to it very fast, right? They responded very rapidly. And then about 20 minutes later, their response time to that, to saying true, was much slower, right? Whereas it wasn't, the inference didn't really matter, right? Our memory, or sorry, our response time to say true did not really depend on retention interval. And this, I guess that doesn't really isn't really important. But the important thing is that the inference is stored in our long-term memory, right? It's another evidence for that. Okay, in the next video, we're going to talk about how schemas can affect your misattribution of how you can have a schema consistent misattribution error. And yeah.